Welcome to a refresher lesson for trigonometric functions, graphing. This video corresponds to the examples on a worksheet packet that can be found at my Teachers Pay Teachers store. In this video, I will explain the skills and steps necessary to complete all of the examples on the worksheet. Please feel free to skip around to engage in the concepts with which you would like some help. So if you have seen any of my previous videos, you know that when we talk about graphing functions, we have to talk about graphing transformations. These are numbers that can be inserted into any parent function, and it will have certain effects on that parent function to create a new graph that's within the same family of functions. And so trigonometry is no different. We can insert these different values for trigonometry as well. And the values that we're usually looking at are the A, B, H, and K values, whether they move the graph up, down, or left, right, whether they reflect the graph through the X or Y axis, or whether they actually stretch or shrink the graph, change the shape a bit. So these numbers will affect our graphs in the trigonometric family also. But when we talk about trigonometry, some of the effects that those numbers have specific names to them. And so we want to talk just a minute about what those names or characteristics actually are before we start graphing. So the first thing to realize is you can see there what the parent function of the sine x graph would look like and what the cosine x graph would look like. In each of these, there is what we would call a 5-point pattern that can be really helpful when you're graphing these. In the sine function, when we're looking at the parent function, for sine, we start at the y-axis. And you can see here the graph starts at a 0. It starts on an x-axis point. And then if we move to the right, we can see that our graph goes up to a maximum point. It turns and comes back down to another 0 where we cross the x-axis. Then it dips down to a minimum point and comes back up to a 0 point before that whole pattern repeats itself. So in one full completion of the pattern, we go from a 0 to a max, back down to a 0, down to a min, and back up to a 0. Now in the cosine function, we are also looking at starting at our y-axis, but you can see here that we actually start at a maximum point on the y-axis. And then we go down to a 0, keep going down till we get to a minimum point, turn to go back up to a 0, and then end the pattern back up at a maximum point. Okay, so knowing this pattern can be really helpful in remembering how to graph your sine or your cosine function. Now, what might affect that is going to be an a value if our a value is less than 0. If it is less than 0, then it's going to have the effect of reflecting our graph through the x-axis, which means that all of the maximum points are going to become minimum points, and all the minimum points will become maximum points. Okay, then we have something called the sinusoidal axis, and that's a big mouthful, but it really is just the horizontal midline to our graph. So normally in the parent function, the sinusoidal axis is going to be our x-axis. That is the horizontal line that runs halfway through our graph horizontally. for both sine and cosine. The value that could affect that is going to be the k value, because k moves our graph up and down vertically. And so if we are going to be moving the graph up or down, then that horizontal line is going to move, and it's going to end up at y equals k. Whatever that k value is, that's where our sinusoidal axis is going to be. Then we have something called the amplitude. And the amplitude is the distance from that sinusoidal axis to a maximum point or to a minimum point. Okay, we're just talking the distance, so it doesn't really matter if we're going up or down. And if we are talking about the parent function, amplitude will always be 1. So this distance right here, from a max point down to the sinusoidal axis, that's what we call the amplitude. And it doesn't matter if we go up to a max or if we go down to a min, that distance is what we're looking at. Now, the value that could affect that is going to be the A value, because the A value causes a stretch or a shrink vertically. So if I end up with a stretch, I'm going to end up with a bigger amplitude. There's going to be bigger hills and valleys to our graph. And so the amplitude ends up being whatever the absolute value of my A value is. I don't care about the negative. Again, the negative affects reflection. It does not reflect or affect the stretch or shrink. And so we're just going to take the absolute value of our A, and that becomes the amplitude. That will become that distance from sinusoidal axis to a max or to a min. Then we have what we call the period, and the period is the amount of space that it takes to complete one full pattern of the function. And this is space on the x-axis. And so normally, if you think about the unit circle, in order to go through all of the possible values of sine or cosine, to go through an entire pattern of sine or cosine, we have to go all the way around the circle, and that is 2 pi radians. So normally in our parent function, that amount of space that it takes to go through one full function, one full pattern, is what we call the period. And it's 2 pi on a parent function. And that's true for both sine and cosine. Okay. The value that could affect this is our B value, because the B value causes horizontal stretches and shrinks. And so if I get a horizontal stretch, it's going to take more space to complete a pattern. If I get a horizontal shrink, it's going to take less space to complete one full pattern of the graph. So we find the period by taking the 2 pi, that is our normal space, our normal period from the parent function, and then we divide by whatever b is. And again, probably technically we should be talking about the absolute value of b, because we don't care if b is a negative value or not. And then finally, we have a phase shift. And with the phase shift, that's really just a special name for horizontal translation. So if we get an h value inside of those parentheses with the x minus h, then it's going to move our graph to the left or to the right. So normally the pattern starts at the y-axis, but if we have a phase shift, then it's going to start at x equals h. And you might want to consider actually drawing a vertical dotted line there as kind of your new y-axis, so to speak, because that's where you're going to be starting your pattern now to sketch your graph. All right, so let's see if we can put some of that into practice here. So we have this first example where we're asked to graph the trigonometric function k of x equals -3 sine of 2x plus 1. So one of the first things I would recommend doing is to identify which parent function we're talking about. In this case, we're talking about the sine, because that is going to allow us to decide what pattern we're going to be doing. So if I'm talking about a sine function, then in the parent function, that means we would be looking at 0, max, 0, min, 0. That would be the normal pattern that we would follow. But then we also want to identify those a, b, h, and k values. So our a value is going to be this -3 out in front. The b value is going to be the 2 that is our coefficient on x inside of the sine function. We're not adding or subtracting anything to the x inside, so h is just going to be a 0. And then our k value is what we're adding or subtracting out here, and that's just going to be a +1. Okay. All right, so with those values, here's kind of the order that I would recommend that you identify things. It can vary a little bit depending on your function that you're trying to graph, but here's kind of what I would recommend. First, based on your k value, determine your sinusoidal axis. It's going to be y equals k or y equals 1. So if I go with a scale of 1, then my sinusoidal axis is now going to be here. So when we talk about zeros, we're now talking about zeros being on that sinusoidal axis, not actually on the x-axis. Then I would look to see if you have any phase shift, because if you do, you're going to want to sort of reestablish a vertical axis as well. We do not have a phase shift in this one because our h is 0. So we don't have to worry about that. Then we're going to take a look at our a and b values. So since a is a -3, that tells us that we're going to have two things to consider. First is that we're going to have a reflection because we have a negative number. And that means that my new pattern is going to be 0, min, 0, max, and then back to 0. So these are going to switch places. And then it also means that I will have an amplitude of 3 units. And then finally, my b equals 2 means that I'm going to have a period, which is 2 pi over that 2, which is going to be pi units. Okay. All right, so we've already got our y-axis labeled. We need to label our x-axis, and that is based on our period. Now, I always recommend to my students that they always go a multiple of 4 units out from your vertical axis, which in this case will be our y-axis. So you could go 4 units out or you could go 8 units out. If there is no phase shift, I tend to go out here to the edge, just so you have more space. If you have a phase shift, then probably you're only going to go 4 units because you need to accommodate that shift. And so if I go all the way out to the edge, that is going to be my full period. So pi there and negative pi in this direction. And then I divide that in half. So that's going to be a pi over 2. And divide it on half this way. So a negative pi over 2. Divide that in half again to become pi over 4 here. negative pi over 4 here. And then we've got our third tick mark, which is halfway between the second and fourth. And that is just going to be 3 of whatever this value is. So if that's a pi to the 4, or excuse me, pi over 4, then this will be a 3 pi over 4. We're just 3 of those units away. Here will be negative 3 pi over 4. Now the tick marks are important because that's where the pattern happens. Okay, so you want to make sure that you have those tick marks labeled well so that you can follow the pattern when it comes time to actually start graphing. All right, so we have taken care of our period. We don't have a phase shift. We've drawn in our sinusoidal axis. So now we're looking at an amplitude of 3 and following our reflected pattern. So I will be starting at the 0 here on the sinusoidal axis. I will be going to a minimum next, and that minimum needs to be 3 units down from my sinusoidal axis. So at my tick mark of pi over 4, I will come 3 units down from my sinusoidal axis, and that's where my minimum point will be. Then at my next tick mark, I'm back up to a 0. Again, 0 on the sinusoidal axis, not on the x-axis. At the next tick mark, I'm going up to my maximum, and that is affected by my amplitude of 3. So counting 3 up from my sinusoidal axis gives me a point there. And then at my last tick mark, I'm back down to a 0 on the sinusoidal axis. Now, to the left of my y-axis in the negative direction, I just continue the pattern. But keep in mind, that means the pattern is that I will be going up if I go from right to left. So from left to right, I went 0, min, 0, max, 0. But now if I'm going to go right to left, I need to go the opposite direction. So I'll be going 0, max, back to 0, down to a min, and then back to 0. And that will give me what we call 2 full periods of graphing, which is usually what's expected. And now that you have those points in, you're going to connect those points with a nice smooth curve. These are not pointy straight lines through these. These are curves. And your graph should look something like that. All right, let's take a look at another sine cosine example here for a second. So here we're looking at graphing the trig function j of x equals 2 cosine of 4x minus pi over 8. Okay. I'm sorry, I miswrote that. Should be pi over 2 here. And now let me explain why I miswrote that. So here's what you need to do before you go through all the steps we did in our previous example. If you go back to our general format for these transformations, you'll notice here that b is outside of the parentheses for x minus h. So before we start doing anything with our graphing, we need to make sure that our function is in that format. So we need to rewrite this first by bringing the 4 out, and that makes this pi over 8 now, since it was supposed to be in pi over 2 to start with. Factoring out the 4 means I have pi over 8 being subtracted from the x. So we are dealing with a cosine function this time, which means at least on the parent function, we would be going max, 0, min, 0, max. If we identify our A, B, H, and K, A is going to be a 2. Our B now is this 4 that's out in front of the parentheses. And our H now is the pi over 8. It is not pi over 2. And our K is just a 0 because there's nothing being added or subtracted outside of the cosine function. So this means our sinusoidal axis is going to stay as the x-axis. Okay. This tells us that we are going to have a phase shift. And since it is a positive pi over 8 for h, we're going to be moving to the right. B equals 4 is going to give us our period. So 2 pi over 4 simplifies to pi over 2. And then since A is only positive this time, not negative, it's going to tell us what our amplitude is, but there's no reflection involved. So our amplitude is going to be 2. All right, so we know that our x-axis is going to be our sinusoidal axis. We're not moving that this time. Because of the phase shift being to the right pi over 8, we're going to want to establish what our x-axis units are going to be. So I'm going to keep this as a scale of 1 on my y-axis. On my x-axis, I have a period of pi over 2. I am going to move that so that I have normally, I'm going to go 4 units to the right, and I'm going to do this from the y-axis for a moment. So this is going to be my pi over 2 mark. And the reason I'm not going all the way out to the end like I did before is because of this phase shift. I need some space to be able to move this. So I'm just going to go 4 units out this time, but I do the same thing halfway, which will be pi over 4. Half of that is going to be pi over 8. And then in between here will be 3 pi over 8. And I'll do that in the negative direction as well. So I've got negative pi over 2, negative 3 pi over 8, negative pi over 4, negative pi over 8. Okay, but then here at pi over 8, I'm going to have sort of the new y-axis. This is where the pattern is going to start from because of that phase shift. And so because I'm shifting 1 unit, 1 box to the right, I need to label 1 more box to the right here so that I have the space to do a full period. So if we're going by 8ths, this is going to be a 5 pi over 8. Now, I don't really need to label that on the negative side because I'm not going further to the left, I'm going further to the right. Okay. All right, so I have got my period. I have drawn my vertical line because of the phase shift, so I know where I'm starting. I know my sinusoidal axis is on the x-axis. So now using my amplitude of 2 and using the normal pattern, I'm going to start at a max of 2. So I'm going to start 2 units up here. At the next tick mark, I'm going to be at 0. Next tick mark, I will be at my minimum, which will be 2 units down from the sinusoidal axis. Then I'm back up to 0, and then I'm up to my max there at 5 pi over 8. Continue the pattern to the left. The y-axis now is just one of my tick marks, so I'll be at a 0 there. Negative pi over 8, I'm down to a min, back up to a 0, and then back up to a max. So I don't actually get all the way to the negative pi over 2 because of the shift. And now I draw in a smooth curve to connect my points. And my graph looks something like that. Now, sine and cosine are probably what you will have to graph most often in your Algebra 2 or pre-calculus classes. And it is probably they're probably going to be the functions that you become the most familiar with because of how many times you'll be asked to graph these. But you may also be asked to graph the trig functions that go beyond sine and cosine, like cosecant and secant, or tangent and cotangent. So I want to take a moment to just show you how I do these. This might be a little bit different than what your teacher does, but this is what I have found works in the past. I am not a big believer in forcing students to memorize a bunch of things. I like to try to show students how they can use what they already know. And so when we're graphing cosecant and secant functions, we know that cosecant is the same as 1 over sine, and we know secant is the same as 1 over cosine. And since I already know now how to graph sine and cosine functions, I want to use that to graph my secant and cosecant functions, rather than coming up with some new set of rules that I have to memorize. So here's what I recommend here. We're going to obviously identify what our function is, which is secant this time. But along with that, we're going to identify that that's the same as 1 over cosine. That's the reciprocal function that goes with it. And that means that based on that, we are going to actually graph the points, just the points, for the cosine function using the same a, b, h, and k values. So in this case, we don't really see any number out here, so we assume that a is 1. We see the coefficient on the x here is 2, so that's our b. We're not adding or subtracting anything to x, so h is going to be 0, and our k is going to be negative 1. So now we're going to graph using those values as if this is just the cosine of x function. So again, this means our sinusoidal axis is going to be y equals negative 1. There is no phase shift, so we don't have to worry about moving things left or right. We are going to have a period that is 2 pi over 2, which will be pi units, and our amplitude will just be 1. Okay, so again, I'm just going to use units of 1 here. Which means my new sinusoidal axis will be there. With a period of pi and no phase shift, I'm going to go all the way out to the edge again to set up my tick marks. So this one will be pi. This will be pi. Oh, sorry, that shouldn't be 2. Let me try that again. That here. Okay, so there's my sinusoidal axis. Here are my tick marks. And this one should be pi for my period, which makes this one pi over 2, makes this one pi over 4, and makes this one 3 pi over 4. Now we'll do that in the negative direction. Negative pi, negative 3 pi over 4, negative pi over 2, negative pi over 4. Okay. And so if we do the cosine pattern, which is max 0, min 0, max, and we do that with an amplitude of 1, we're going to start here on the y-axis, 1 unit up from the sinusoidal axis, which means we're actually starting right there. Then we come down to 0, down to the min, which will be 1 unit down, back up to the 0 on our sinusoidal axis, and then back up to our max. Continue the pattern to the negative side. Okay, and then stop for a second. Now, these are the points from the pattern for the cosine, but we are not actually graphing cosine. We are actually graphing secant. And secant is actually 1 over cosine. So what that means is we don't want cosine x to equal 0 because it's actually in the denominator. And again, 0 meaning anything on the sinusoidal axis. So if I go to my graph here, every time I had a point on the sinusoidal axis, for secant, I need to put a vertical asymptote at that x value. Okay, so there's another one on the sinusoidal axis, vertical asymptote. And one more here, vertical asymptote. Okay. And so then I'm just left with the maximum and minimum points from my pattern. And what I'm going to graph is parabola-looking graphs. They're not exactly parabolas, but they look like U-shaped parabolas. And they're going to open up or down depending on whether I'm at a max point or a min point. We're going to use those points like they're the vertex. So if I'm at a max point, we're going to have the U open up and stay inside of our asymptotes. If it's a min point, we'll have our U open down and again stay inside of our asymptotes. Now, if you want to be more particular, you can pick some actual points to plot, but usually we're just looking for a sketch. And so just doing the parabola U shapes from these points is usually good enough. So we're back to a maximum point. So our U shape is going to go up, then back to a min point. So we open down, and then we've got another half of a U there to open up. So that's what the graph of a secant function would look like. And you can do the same with cosecant. If it's a cosecant, you would graph it as if it was sine with the same a, b, h, and k values, and then put your vertical asymptotes wherever you have zeros on your sinusoidal axis, and draw your U shapes from the maxes and the mins. Finally, with tangent and cotangent, I actually kind of recommend the same thing. We know that tangent and cotangent can be rewritten as sine of x over cosine x, or cosine x over sine x. And so again, since we already know how to graph sine and cosine, and we will be getting better and better and better at sine and cosine, I'm just going to use that to figure out how to graph my tangents and cotangents. Okay, so here's what I mean by that. In this case, we're looking at the tangent function. So we are considering the equivalent of sine of x over cosine x. Okay, so if we look at let's get rid of that for a second, our values a, b, h, and k, we've got 2 for a, 1 for b, 0 for h, and -1 for k. So just like doing sines and cosines in our previous example, we want to actually graph the points of sine of x and cosine of x with these a, b, h, and k values. So the sinusoidal axis is going to be at y equals -1. We have no phase shift. With b equal to 1, our period is just going to be the 2 pi that it is on a parent function, and we will have an amplitude for sine and cosine that is 2. Now, in the actual tangent, it's not called amplitude anymore because it's not a max or min point. But when we're doing the sine and cosine, the amplitude is 2. When we're talking about the tangent, the 2 really just represents a vertical stretch. Okay, so +5 here, -5 here, sinusoidal axis at -1. No phase shift. We're going with a period of 2 pi. And with no phase shift, I don't need extra space, so I can space this out to go 2 pi here, pi here, pi over 2, and then 3 pi over 2 for this one. We'll do that in the negative direction as well. -2 pi, -3 pi over 2, -pi, -pi over 2. All right, so let's look at sine of x in blue. Okay, if I was doing sine of x, I would be starting at the 0, which is here on the sinusoidal axis, going up to a max, 0 max, 0 min, 0. So going up to a max that's going to be 2 units above the sinusoidal axis, back down to a 0, down to a min that'll be 2 units below, back up to a 0. Continue my pattern to the left with the negatives. And that's where the points for sine would be. Now, again, I'm not connecting those points right now. Before I do anything, I want to take a look at where my cosine points would be. So if we do cosine in green, again, using the pattern of max, 0, min, 0, max, and again with an amplitude of 2. So I would be starting here 2 units above, 0, 2 units below, 0, back to a max. Continue the pattern to the left. And we look like that. Okay, now that might look a little bit messy, but what we really need these dots for is to just tell us what's going on with our tangent function. Okay, so in the tangent, it is the cosine that's in the denominator. So we do not want cosine x to equal 0, which means any place cosine x has a 0 on the sinusoidal axis, that's where we're going to put vertical asymptotes, just like we did with secant and cosecant. Cosine x was green, so anywhere we have a green dot on the sinusoidal axis, we are going to draw a vertical asymptote. So one there, one there, one there, and one there. Okay. Now, if it is the sine of x, because that's in the numerator in this case, if that's equal to 0, then any place we have the sine of x on the sinusoidal axis, that's actually a point on our tangent. So these blue points on the sinusoidal axis are points on our graph. Okay. All right. Now, there are a lot of reasons behind this, but for simplicity's sake, it's easiest to just say if we are dealing with a tangent, then you are going to go halfway to the right of this 0 between the 0 and the vertical asymptote, and you're going to go to the a value. If you go to the left, you're going to go to the negative a value. So because this is tangent, if I go halfway between this point and this asymptote, and then go up the a value, which is 2, I have a point right here. Okay, I'm going to do the same thing here. From this point, if I go halfway to the right, I'm going to go up 2. If I go halfway to the left, I'm going to go down 2. And so you see those points are in line with our max and min points that we had. Okay, so same thing here. From this point, going to the right, up 2, and going to the left, down 2. And you just keep doing that. To the right, up 2, to the left, down 2. And then here we only need to go to the left and down 2. Okay. Now, one thing to keep in mind, if it is the cotangent, you do the opposite. If you're going to the right, then you go negative a. If you're going to the left, you'll go to a. Okay, so that's one thing you do have to keep straight between tangent and cotangent. All right, well, with secant and cosecant, we drew in curves that looked a little bit like parabolas. With tangent and cotangent, we're going to draw in curves that look a little bit like the cubic function. So this will just curve up like this, getting closer to the asymptote. Then here where we have a full section, we're going to come up, hit the points, do a little bit of a curve, and make it look like that. Again, it's a little bit like a cubic. It's not entirely cubic in that it can't go as wide as you want it to. It does have to stay inside of those asymptotes, but it has kind of that shelf look to it, which we relate to cubic graphs. And so that would be your tangent function with a vertical stretch of 2. So with the tangent, that's really a vertical stretch. And with a vertical translation of -1. All right, I hope you found this to be helpful. If you would like to see other concepts that you need to refresh or review, please check out my Gordon Global Math page on YouTube. Videos covering Algebra 2 and pre-calculus concepts will be added throughout the spring of 2025. Thanks for watching.